All right, welcome back to the deep dive. We're jumping straight in today.
Sounds good.
So we've talked about AI generally, and prompt engineering is a way in.
Right, how we interact with it.
Exactly. But now let's get into the how. How are these AI capabilities even possible? What's actually going on under the hood?
Yeah, that's the core of it today. We're looking at the source materials you've gathered, the research, the notes. What do they say are the fundamental building blocks?
The foundations.
The foundations, yeah. The approaches that really power the AI applications we're starting to see everywhere. Think of it like the engine room of the ship.
Okay, the engine room. And our mission then is to unpack what these specific sources are telling us about that engine room.
Mm-hmm.
How do these big concepts actually, translate into the systems that can write an email for you or recognize a face or suggest your next movie?
And it's crucial, right? As one of the sources points out, understanding this isn't just like academic curiosity.
Right.
No, because modern AI, especially the kind we're focusing on in this level, the LLMs, the generative AI stuff, it heavily relies on these techniques.
Okay.
The source mentions things like learning, reasoning, language understanding as key AI goals, but it really flags machine learning as being absolutely central today.
So machine learning, that's our starting point. Often hear it called ML.
Yep, ML. And the sources definitely position it as a cornerstone, maybe the cornerstone of modern AI.
So what is it? Fundamentally, how does it differ from just regular programming?
Well, traditionally, you'd tell a computer exactly what to do, step by step, for every possibility.
Right.
Yeah, like a recipe.
Exactly. Machine learning flips that. It's about building systems that learn from data. You don't give it the recipe. You show it thousands, maybe millions of examples of finished dishes.
And it figures out the recipe itself.
Pretty much. It identifies patterns, correlations, relationships in that data, and essentially teaches itself how to perform a task, like making a prediction or a decision, with minimal human hand-holding after the initial setup. Okay, so instead of coding, if email contains this word, then it's spam, you show it tons of spam emails and non-spam emails.
And it learns the characteristics. It learns what tends to indicate spam based on all those examples.
And the sources say this approach is why it's so foundational now.
Absolutely. It's that ability to process just massive amounts of data and find complex patterns that we might not even see ourselves.
Right.
That's what drives success in so many areas. Fraud detection, those product recommendations you see online, even facial recognition. It scales with data in a way old-style programming just couldn't. The learning is the key.
And this learning connects directly to the large language models, the LLMs, that are such a focus for us here.
Directly. One source explicitly says modern AI, especially the kind powering LLMs, relies heavily on these ML techniques.
Makes sense.
LLMs are machine learning models, fundamentally. They learn the patterns of language from unimaginable amounts of text data. That's how they work. Without ML, you just don't get LLMs.
Okay, got it. So ML is the big umbrella. But I keep hearing about deep learning, DL. That seems to be everywhere, especially with the latest breakthroughs.
Yeah, deep learning is definitely highlighted in the materials as a particularly potent type of machine learning.
A type of ML.
Exactly.
Yeah.
It's a subfield, but it's the one behind a lot of the really cutting-edge stuff, including, yes, the very sophisticated LLMs we're talking about.
So what makes it deep? Is it just more complex ML?
It refers to the structure it uses, artificial neural networks, inspired loosely by the brain. Instead of maybe one or two layers processing information, deep learning networks have many layers stacked on top of each other. They're deep in that sense.
And why does having many layers matter?
That's the magic. That depth allows them to learn things hierarchically. So the first layer might learn simple features, like edges in a picture or maybe common word pairings in text. Then the next layer combines those simple features to learn slightly more complex things like corners or simple phrases. And layer by layer, it builds up until the top layers can recognize whole objects or understand the sentiment of a sentence or grasp really complex concepts.
So it's like building understanding from simple blocks up to complex ideas layer by layer.
That's a great way to put it. And, while the sources might not define DL in extreme detail, they imply its importance, and we know it's been revolutionary.
In what areas specifically?
Well, computer vision is a huge one, recognizing images, medical scans, that kind of thing. But crucially for us, it's massively advanced natural language processing.
NLP.
Yeah, NLP, which is what makes these powerful LLMs possible in the first place.
Okay, that brings us right to it. Since this level is so focused on text, on LLMs, natural language processing must be, well, absolutely critical.
Oh, totally non-negotiable. NLP is the whole field of AI dedicated to computers understanding and using human language.
Bridging the gap between how we talk and how computers think.
Exactly. It's about enabling computers to interpret meaning, figure out intent, even generate language that sounds natural. One of the sources actually lists language understanding as a core AI capability that's pure NLP.
So this is how the AI understands our prompts when we use prompt engineering.
That's the mechanism, yes. NLP is the engine behind virtual assistants, understanding your commands, translation tools working, sentiment analysis, figuring out if reviews are positive or negative. Chatbots, text generators, even your grammar checker to some extent. And the recent leaps in NLP, largely driven by those deep learning techniques we just mentioned, are precisely what enabled the LLMs we have today.
So our whole journey with prompt engineering is basically interacting with advanced NLP systems.
Fundamentally, yes, you're guiding an NLP system that's been trained using ML, often DL.
Right. Now, we're focusing on text here, but AI isn't just about language. You mentioned computer vision, and one source talks about perception.
Yes, perception is another key capability the source material brings up, and computer vision is the main player there.
Letting computers see.
Pretty much. It's about training AI to interpret images and videos, recognizing objects, reading text in an image, identifying faces, understanding a scene.
Which is crucial for things like self-driving cars, I imagine.
Exactly. Autonomous vehicles, medical diagnosis from scans, security surveillance, loads of applications, foundational stuff.
Are there other ways AI perceives things? Right. Beyond vision and language?
Oh yeah. Think about audio. Speech recognition, turning your spoken words into text for the AI to process.
Like talking to a smart speaker.
Right. And the reverse, text-to-speech, where the AI talks back. There's also AI that works with structured data, like spreadsheets or databases, finding patterns there for things like, say, business analytics or recommendations.
So it's about interacting with all sorts of information.
That's the goal. Making AI systems that can handle information in many forms. It even ties back to an idea in one source about AI using external tools. Those tools might deal with different data types, images, sound, structured data.
Okay, so we have this amazing toolkit. ML, DL, NLP, computer vision, audio stuff. But you said earlier, these things don't just happen. What else is absolutely essential?
Two things the sources really hammer home, and frankly, it's just obvious when you think about the scale. Data and computing infrastructure.
Data seems like a given for machine learning. Learn from data.
Yeah.
Needs data.
It does, but you can't overstate it. ML and DL models are hungry for data, and not just any data. Vast amounts of high-quality, diverse data are needed to train them effectively.
Quality matters as much as quantity.
Absolutely. The performance, the capabilities, even the biases and limitations of an AI model are a direct reflection of the data it learned from. Remember the source talking about the largeness of LLMs?
Yeah.
That largeness isn't just the model size, it's directly linked to the massive scale of text data they consumed during training.
Okay, so data is the fuel.
Mm-hmm.
What about the engine itself? The computing power?
Right, the infrastructure. Training these incredibly complex models, especially the huge deep learning ones like LLMs, takes staggering amounts of computational power.
More than my laptop can handle, I guess.
Oh, way more. This need for power has driven the huge growth in cloud computing platforms offering AI services and the development of specialized chips like GPUs and TPUs.
GPUs like in gaming?
Similar tech, but often optimized differently. They're great at the kind of parallel calculations needed for training neural networks. Without that specialized hardware and massive cloud infrastructure, building and running today's most powerful AI just wouldn't be practical.
Okay, so let's put it all together now.
Yeah.
We have machine learning, deep learning within that, specific fields like NLP and computer vision, all fueled by data and running on powerful infrastructure. How do these bits combine to make, say, a virtual assistant work?
It's really about layering these things. So your virtual assistant first needs speech recognition to turn your voice into text that's audio processing.
Got it.
Then it uses NLP to figure out what you meant, your intent. What action are you asking for? What information do you need?
Okay, understanding the request.
Right. And underlying all that are ML and likely DL models that have been trained to map requests to actions or find the right information, and then maybe NLP again to formulate a spoken response using text-to-speech.
So multiple pieces working together.
Yeah.
What about generating text, like one source mentioned for writing assignments?
That leans heavily on an LLM, which, as we've said, is fundamentally a deep learning model
Right.
built using advanced NLP techniques, trained on a colossal data set of text, all running on serious computing hardware.
And it generates text by predicting the next word.
Essentially, yes, based on the patterns it's learned the statistical likelihood of words following other words in context. That's the power it learned how to do this from data. Nobody explicitly programmed grammar rules for every single sentence structure. It's learning, not just executing instructions, as another source emphasized.
And prompt engineering is our way to steer that learned ability.
Precisely. You're providing the context and direction for its learned generative capabilities.
So for you listening, getting a handle on these foundations, ML, DL, NLP, it really gives you the why behind the what you're doing. It explains how these tools, especially the LMs we're focusing on, actually work underneath it all. It demystifies it a bit.
It really does. It provides that crucial context. So you're not just typing into a black box. You understand the principles at play. It helps you interact more effectively.
Okay, so quick recap. Modern AI, built on foundations like machine learning, boosted by deep learning, applied through fields like natural language processing and computer vision.
And all of it absolutely dependent on huge amounts of data and powerful computers.
Understanding these building blocks is key context for actually working with AI, especially for using prompt engineering effectively with LLMs.
Definitely.
And this leads us nicely into our next deep dive. We'll build right on this, looking specifically at where these large language models and generative AI actually came from, their origins, their evolution.
Yeah, tracing that history. But before we wrap this one up, here's something to chew on, building directly on that idea of learning from data.
Okay.
If these incredibly powerful systems learn their skills primarily by soaking up patterns from the data they're fed, rather than being explicitly told right from wrong or how to handle every situation, what does that tell us about the huge impact of the data itself? Meaning, what about the biases in that data? What about the things the data doesn't cover, the limitations inherent in it? How much does the nature of the training data fundamentally shape the intelligence, the behavior, maybe even the flaws of the AI we end up interacting with?
That's a heavy question. The data defines the AI's world.
Something to think about. We'll pick it up next time.